So for our example here, we're going to look at a solution of vinegar. So vinegar, as you're familiar with, is a solution of acetic acid with a bunch of other stuff in it, of course, depending on what you make the vinegar from. But the concentration, I looked this up a year ago or something, the concentration of acetic acid in vinegar is roughly 0.83 molar, based on, I think, a 5% vinegar solution. Or maybe 1%, I can't remember. Anyway, we're working with this concentration. And the question is, for our vinegar solution that we have, what's the pH? So we have the concentration. One of the other pieces of information we need to know is, what's the Ka? So we can look this up in our textbook in the table, and we'll find that for acetic acid, the pKa is listed as 4.56. Now we're going to need the actual Ka value, not just the pKa, to do this calculation. So if we want to find Ka, we remember the definition of P here. So we have to do the opposite of negative log base 10. So we take 10 raised to the negative 4.56. That will give us our our Ka value. All right, and so our Ka value is equal to, if we do that calculation, 2.75 times 10 to the minus 5. You can plug this into your own calculator and make sure that my numbers are correct here. Okay, and so we went through it. So we know that what we need to do is that Ka will equal x squared over f minus x. We went through in the last video where this equation comes from. And f will be this concentration here, right? That's the concentration of the acetic acid. So now we can just plug in our values, right? We have 2.75 times 10 to the minus 5 is equal to x squared over 0.83 minus x. And we'll go ahead and solve this using the quadratic formula. So I'll do this the long way. You can also, of course, use a solver on your calculator or something like that. But we can just rearrange this mathematically. We have x squared is equal to 2.75 times 10 to the minus 5 times 0.83 minus x. Then we can expand that out. X squared is equal to 2.283 times 10 to the minus 5 minus 2.75 times 10 to the minus 5 times x. And then we'll want to write this in the form that we can use the quadratic formula. So we'll have x squared plus 2.75 times 10 to the minus 5 times x minus 2.283 times 10 to the minus 5. And this number, of course, is just coming from these two values multiplied together when I multiply this out. All right, and that is equal to 0, and that's the formula we need. That's the form we need for the quadratic formula. So in case you don't remember, this is x is equal to negative b plus or minus the square root of b squared minus 4ac. You may not have thought about this for a while. Divided by 2a. Oh, that moved on me. All right, let's stop that. All right, too much zoom. Get me back to 100%, please. That's the opposite, and we should be good. Okay. So my hand dragged this over, so this should be a 2a down here. And this is for where we have ax squared plus bx plus c equals 0. Okay, so that means we can plug this in and get that x is equal to negative 2.75 times 10 to the minus 5 plus or minus the square root of 2.75 times 10 to the minus 5 squared minus 4 times 1 times negative 2.283 times 10 to the minus 5. All that under the square root, divided by 2 times 1. Okay, and so if we go through that, we'll get two roots. One of them will be negative. We ignore the negative one. We get a final value of 4.76 times 10 to the minus 3. And just to remember, right, to not lose sight of what we're solving for, that's equal to our hydrogen ion concentration. So if we want the pH, let's say pH is equal to negative log base 10 of 4.76 times 10 to the minus 3, which is equal to 2.32. So vinegar is, as you would expect, quite acidic, which is not a surprise. If you've ever eaten something with vinegar in it, right? It's quite bitter. That's that acidic flavor that you're tasting. So that is the basic idea of how we would go through and find the pH of a weak acid solution.